In this module, we're going to talk about the dilution equation. So first, let's be clear as to what we mean by dilution. Dilution means changing the amount of solvent in a solution. Now, most of the time, that means adding more solvent, adding some more water, diluting it. But we can go the other way too. If we evaporate some of the water, we can decrease the amount of solvent, and still what happens is we change the concentration of the solute. So it works either way. So there's a dilution equation for you right here. C1V1 equals C2V2. Now, you may have seen this as M1V1 equals M2V2. That's fine. The reason I like to write it this way is because this works for different units of concentration than just molarity, which we'll get to later on. We're not quite there yet. But I'm kind of looking ahead here, and we'll write it this way. If you prefer M1V1 equals M2V2, hey, knock yourself out. So C1 is going to be the concentration, or for now, the molarity of the solution before we dilute it. V1 is how much of that solution, which we call the stock solution, that we're going to take out and dilute, change the amount of solvent in. C2 is the concentration after the solution's been diluted, and V2 is the volume of solution we have after dilution. The ones are before, twos are after. Initial is 1, final is 2. So now let's do an example, which may or may not seem familiar to you. Calculate the concentration of cobalt-2 ion, remember the square brackets mean molarity, in a solution that's made by diluting 2.12 milliliters of a 0.1915 molar stock solution of cobalt-2 ion to a final volume of 5.11 milliliters. So a stock solution just means what we made up initially, and now we're going to dilute it. One thing real quickly back here, it doesn't matter what units your volume is in as long as it's in the same units on both sides. So liters and liters, milliliters and milliliters, heck, quarts and quarts, bushels and bushels, doesn't matter. Here, we're just going to keep it as milliliters. So let's work it out. So the dilution equation, in this case, what we want is the concentration after dilution. So that's C2. We rearrange this. Check my algebra. We get V1 over V2 times C1. And all we have to do now is plug in. We didn't have to change the units of the volumes because they were the same, both in mils, right? So we took 2.12 mils of the stock solution, that's our V1, and diluted it to 5.11 mils. That's our V2, final volume. And C1 is the initial concentration of the stock, in this case, 0.1915 molar. Plugging in, we get 0.0794 molar for the concentration of the diluted solution.